Hello everyone, this video is recorded for BiophysicalLab in Department of Chemistry, University of Florida. We will talk about the part 2 data discussion by using Matlab. Okay, some background information. During the first week, we should already get the NMR spectrum of N-acetyl L-proline in different conditions, and we have already learned how to assign each peak to different molecular conformation. You may notice that the integration of each NMR signal is associated with the cis and trans molecular conformation. So through the integration of NMR signal, we can determine the cis and trans ratio. You may encounter also another phenomena is that if you didn't prepare your sample very well, you may introduce some H2O water in your sample. This will generate a big and huge water signal. Will this background signal influence your integration? Of course, yes, because integration is just the area below your NMR signal. So right now your integrated NMR signal including two parts. The first part is the gray one. You can use this part to extract your ratio of molecular conformation, and the yellow part is actually from the water. Is the signal. We really want to get rid of it. So right now our task is including two parts. The first part, if your background is okay, we can just do integration to extract the ratio of the molecular conformation. And secondly is that if you have background signal, you need to get rid of this background signal and then do integration. Actually, we can use Lorentz curve to feed this homogeneous broadened water signal. In this video, we will cover the following 5 topics. After the lab section, a lot of students give me feedback saying that it's really difficult to use Matlab and file manager in this online system. So we first talk about it, how to use it. And later on, I will give you a quick Matlab tutorial on how to use it to plot and the integration on the NMR spectrum. And later on, I will just discuss background subtraction. And finally, we will talk about the linear fitting of the data. So right now, we are going to log into the apps.ufl.edu. So the first time when you just log into this website, you may require to install the Citrix receiver. Try to install it, and after you install the software, you may require to enter your username and password. This is a UFID, and so log it into the system. After you log in the system, you will see two sections, one favorite section and one app section. The first thing you may probably want to do is that find the program. So right now we are going to find the Matlab. So after we find the Matlab, we just click into a detail. There's the add to favorite, so we click that, and we are going to find the other software. So it's a file, search the file, so go to a detail and then add to a favorite. So go to the favorite section, you may find that there's two software in your favorite. So this is the Matlab software you want to use, and the second one is the M Drive file storage software. This software will allow you to read and write and transfer files between your local computer to the M Drive system, and this Matlab will only work on your M Drive system. So right now we are going to open the Matlab. So there will be very important two pop-up window. You will see the first one is an online application is time to access your file on your computer. You will need to allow it. And second one is that online application is attempt to access information on the device, and you will also need to allow it. So right now Matlab and the M drive file system can have the full access to your computers. Right now we can test whether it's true. So right now we are going to transfer some files from the local computer to the M drive system, the Friday data, and one function called Lorentz feeding, and we just copy it, Control C, and go to your M drive system. You can see that this is an M drive folder. You just paste it, Control C. You will see that the file is over here. So right now we are going to first import the Friday data. So right click it, and there's the option of import data, and we can select the import selection. Right now you will see the ppm, and that is your x-axis data, and the intensity y-axis data. You can just input right now to the command window, plot ppm and the intensity data. So this is a NMR spectrum. You got it. And if you zoom in from the first area, you will notice that your background is not completed zero. So it's a minus something. So right now you want to get rid of the background. So how to get the background data? One way you can do is that you can set the background variable is equal to the mean value for intensity of the first 100 data point. Right now, click it. It's minus 0.113. Double check the figure. It's roughly the same. Right now we are going to subtract the background. Intensity is equal to intensity minus background. And we can plot it again. Right now we can zoom in and double check. The background right now is pretty good. Up to now, you may have one question in your mind. Is it necessary? Must we enter the command in the command window each time we want to plot the data? For example, we need to enter a lot of the plotting command. The answer is yes, there's an easier way. You can see that there's a toolbar, there's a new script. If you click that, there will be a window called the script window will pop up. You can copy and paste all the previously command and save it in this script, so that you can just run this script for all of your data. So right now you can see that I have already copied all the command to the editor, and also make a note. This note will not execute when we run the script. Right now we are going to save the script. Control S. We can see save it as data process. Right now we clean all the worksheet. We can use clear. You can see there's nothing in the worksheet workspace. We can reload the Friday data by import the data and import selected. Then we can run the script by Control Enter. We can see that it should be already background eliminated. Pretty good. So next we are going to do is do the integration. We can use a function called CumSum to integrate all the data and form another integrated vector. Integration is equal to CumSum of intensity. And then plot your intensity with their integration. ppm. Right now we can see that there's 4 steps. That is a 4 integration of your anomaly signal. You may see that the integration signal is much higher intensity than your previous NMR signal. So you may adjust the NMR signal a little bit to make it comparable to your integration. We can now achieve that by times the maximum of the integration. And divide the maximum of your intensity. Save it and then run it again. Now we can see that, and there's a cursor, data cursor. We can use this function to extract the value on your integration curve. For example, this one y value is about 20,000, 23,000, and there before that y value is 6,000. So right now you can just subtract these two values to get the integration of your NMR peak integration value over this peak. So let's clear the workspace again, and we introduce our Monday data. Same process, and we want to copy our previous script and separate by double percent mark. Monday. So we save it and then Control Enter to run the script. We can see that indeed the water signal give a huge integration signal, and we can zoom this part in. We can see that the water signal indeed influences the first two integration and doesn't influence the third and the fourth one. So right now we are going to try to get rid of this big water signal. So what we can do is that before we do anything, we can fit our NMR signal with Lorentz curve. Y fit is equal to Lorentz intensity. And we can use a double % mark to separate them. So right now we want to clear the whole workspace and then import the data again. We can see that although it has some misfitting, it's fit most of the water signal very well. So right now we can just subtract the whole background by intensity is equal to intensity minus y fit. And then do the rest of the part. Right now we can see a clear NMR spectrum and also the integration, and we can use the curves to get the integration a value. One thing we need to notice that we need to click the nearest point according to the NMR signal as possible. So we can use the y, this y value as the initial point, and this value as the end point, end integration point, and the same for this one. This is the end of the integration because this one is the end of the NMR signal. So that's it. So in the last part of this video, we are going to talk about how to plot error bar in your plotting and also do the linear fitting. So this is the conductivity data versus your concentration. Y is conductivity and X is your concentration. And we can use error bar function to plot your X and the Y and the error of your Y data to plot it. So this is a figure, and you can enlarge it and use this cursor and double click any area of your figure, and you can change the x-axis by adding some label, for example concentration, y to be conductivity. Right now we are going to calculate the equivalent conductivity versus the square root of the concentration. Only thing you need to remember is that you need to add a dot before the regular operation. We can use curve fit tools to fit our equivalent conductivity. We can use the default fit name and the x data to be the square root of the concentration, square root of x, and the y data to be the equivalent conductivity. So it is y equal. So you use polynomial fitting model and the degree of 1, and this is a final fitting results. One last thing probably I want to let you know is that we can always use Google to search for the interest for the thing or the question you have in the Matlab. For example, if you want to know how to do Lorentz fit in Matlab, you can search, for example, Lorentz fit Matlab. There is a lot of searching results. In the future, you may find that Google is really helpful if you want to learn Matlab. Hope you enjoy. Thank you very much for watching.